So hello guys. So in this video, we'll see about we'll learn about Apache Cassandra. Okay. So Apache Cassandra is an open source, highly scalable NoSQL database. Okay, designed to handle large amount of data across distributed systems with high availability. Okay. So NoSQL database means so it works on key value. Okay. Basically like unstructured data we use for. Okay. And it's designed to handle large amount of data across distributed systems. So distributed system means so like multiple systems, they are connected each other. So that is nothing but distributed system. So the multiple systems, they compute a task and they all are connected and perform a task. That is nothing but distributed system in simple terms with high availability, okay, fault tolerance, and no single point of failure, which means always whenever you request, right, the system is available. Fault tolerance. Fault tolerance means like if a failure happens, okay, immediately there is a backup. Okay, so they where you can fetch the data and no single point of failure. So no single point of failure means it ensures that the system ensures that there is no failure at all. So that is nothing but Apache Cassandra. These are the features and what it is. Okay. So it was originally developed by Facebook and it is widely used in scenarios where performance, scalability, and reliability are crucial, which means performance, scalability. Scalability means like you can scale up or scale down as per the application demand, okay, and reliability are crucial, such as applications like IoT, big data, and real-time applications, okay. So in detail, we'll see what is Apache Cassandra is. So key features of Apache Cassandra is, so they are a distributed architecture, okay, which means Cassandra is designed to work in distributed environment where data is replicated across multiple nodes and data centers. Okay. So the data, whatever we have, right? So that data will be replicated across multiple nodes and data centers. Okay. This ensures fault tolerance, high availability, and horizontal scaling. Okay. In one video, I'm planning to explain you about vertical scaling and horizontal scaling. So in detail, we will see. Meaning you can add more nodes to handle increased data loads. Okay. In simple terms, guys, horizontal scaling means you can add more nodes to handle increased data loads, which means you have a system. Okay. If you want to scale it horizontally, means what you do, you increase the storage as per your application demand. That is nothing but horizontal scaling. So here in Apache Cassandra, it supports horizontal scalability, which means you can add more nodes to handle. You will have here we have multiple nodes. So multiple nodes will be having a different data. I mean like replicated data, isn't it? So you if you want to handle increased data loads, increased data loads, which to handle that increased data loads, what you will do, you will add more nodes. That's it. Okay. So the other features are like NoSQL database. I think you know about NoSQL database, I believe so. So it uses a NoSQL model where data is stored in a flexible schema, meaning that tables can store different types of data without predefined schema. Key value column based. Okay. This makes it suitable for semi-structured or unstructured data. Okay. Unstructured data is basically like, you know, okay, this also, this semi-structured and unstructured data, these are like basics, guys. Like we have to know, we should not ignore this. So this video and scaling semi-structured and structured data, I'll put in a separate video. Okay, structured data means like where, okay, you have a proper tables. Okay. Name, first name, last name, like that. We follow the data in a table format. Okay, that's like structured. Okay, unstructured means like, okay, consider some videos, images, something like that. Okay, so those are like, you don't know whether it's structured or unstructured. Semi structured basically means, it's like, one second, guys. Sorry, guys, there was a disturbance. So, okay, where I was, okay, structured and unstructured, right? Basically, structured means where, for example, like, okay, unstructured data are like something like, okay, consider an email. Okay, so date and time we have. Okay, so that is something like unstructured. Okay, just a moment, guys. I'm getting a disturbance here. 2 minutes. Mm. Sorry, guys. Yeah. So yeah, I was explaining about unstructured and structured, right? So unstructured, okay, sorry guys, in simple, okay. Unstructured means nothing, okay. Consider email messages where you have multiple data, okay, and also audio and video, images. These all are unstructured data, okay. So, yeah. Then what is the next point? High availability and fault tolerance. So Cassandra is designed to be always available, even in case of nodes failure. It automatically replicates data across multiple nodes in the cluster to ensure high availability and no downtime, which means, okay, high available and fault tolerance. Cassandra is designed to be always available, always, even in case of node failure. Even the node fails also doesn't make any difference, but Cassandra is always up. It automatically replicates data across multiple nodes in the cluster to ensure high availability and no downtime. Okay. Eventually consistent. Okay. Cassandra follows an eventually consistent model. Okay, in my previous video, I explained you what is that eventually consistent model. If you want, you can go and check once. Meaning, data might not be immediately synchronized across all nodes, but will eventually become consistent. It provides tunable consistent level, allowing you to choose between strong and eventually consistent based on your use case. Okay, here what he is telling is by default it is eventually consistent data. Eventually means, for example, in a node, you do any operation, okay, write or read something, okay. Since it's SQL, right? So the data, whatever you do operation, right, that it takes some time, propagation to replicate in another node. Okay. If you trying to read the data from the other node, it will take some time. Okay. But in strongly consistent model, it's not in, I mean, like, sorry, in eventually consistent data, what happens? Like, you try to read the node, since propagation there in the data, so it will give a stale data, which means it's not up to date data you will receive. But in strongly consistent model, what happens? You enforce the system to respond up to date data. That's it. That's the difference. Okay. So next is write heavy workload. So Cassandra is optimized for write intensive application with high throughput requirement. It handles high volumes of data without bottlenecks by distributing the load evenly across all nodes. Means write heavy workloads, which means Cassandra is optimized by write intensive application, okay, with high throughput requirement. It handles high volumes of data without bottlenecks by distributing the load evenly across all nodes. So it will distribute the high volume, it handles high volume of data without bottlenecks. Okay, by distributing, see, without any interruption, it will handle high volume of data by distributing this workload to all nodes. So since there is a different node, it will take care of handling the load. Okay, use cases we'll see. IoT data management, collecting